Hello everyone, welcome to PUNAM'S classes. In this video, I will explain about properties of rational number. We will discuss about closure property, commutative property, associative property, distributive property, additive inverse and multiplicative inverse. So let's go ahead with few examples for closure property. Before that, we need to understand what is closure property. Closure property states that when we have two rational numbers, then whatever operations we do with those two rational numbers like addition, subtraction, multiplication and division, the result will also be a rational number. Like in case of addition, let's check. We'll take two rational number and we'll see the result is coming equal to rational number or not. Let's check it out. So I have taken two rational number as 5/2 and the other rational number as 3/2. Here I have taken the denominator same. So here in case of addition, we'll check whether the sum is coming as the rational number or not. So let's check it out. Here the denominators are same, so we'll have the same denominator as 2. 5 plus 3, so that's equal to 8/2, and finally we are having 2 ones are 2, 2 fours are 8. So we are having 4/1, which is equal to 4. So here we can see that this is a rational number. This is also a rational number and this is also a rational number. When we have added both the rational number, we have seen the sum is also equal to rational number, as it is in the form of P/Q. Let's check for subtraction. Again, I'll take the same rational number, 5/2 minus 3/2. So here again the denominators are same. When the denominators will not be same, I have already uploaded how to do the following sums. When the denominators are not same, we have to take the LCM of the denominators and make it equivalent. So here the denominators are same, so we'll just copy down the denominator, and here numerator would be 5 minus 3. That's equal to 5 minus 3 is 2, 2/2, that's equal to 1. So here in this case, it is also a rational number. So it's true for addition also and subtraction also. Let's check it out for multiplication. The same number, let's check it out. 5/2 multiplied by 3/2. So here we have 5 into 3, numerator gets multiplied with the numerator, that's 15, divided by 2 into 2, that's 4. So 15/4, obviously it's in the form of P/Q, it's a rational number. Okay, now let's check it out for divisions. What we can do is, let's take again the same number, 5/2 divided by 3/2. We have already studied previously like how we operate this, like how we do it. 5/2 will write it as it is. Division changes into multiplication, and then the second number gets reciprocal, so it's 2/3. So this 2 and 2 will get cancelled, and then finally we'll have 5/3. It is also a rational number. But there is a condition. If the second number is 0, in case if it is 5/2 divided by 0, then is it going to give us rational number? No. Anything divided by 0 is not defined. We cannot divide any number by 0. So it is closure property holds for multiplication, but it doesn't hold for division. So closure property holds for addition and subtraction and multiplication, but it doesn't hold for divisions. I hope so it is clear. Now let's move on to the next property, that is commutative property. Commutative property. Here we will again see what is commutative. We have already studied these all things in our whole numbers. Whole numbers, integers, it's already there. What it says that when we have two numbers, two rational number, suppose A and B are two rational number, the result will be same even if we change the order of the numbers. Like if we write B first and then we add it with A, then the result would be same. Closure property, commutative property states this, that the result is always same even if we change the order of the numbers. So let's check for addition, subtraction, multiplication and division whether it is true or not. So let's check it out. So I have taken one example over here. Let's check. Again the same number I am taking, 5 by 2 plus 3 by 2. What it says that A plus B should be equal to B plus A. So I am checking for the LHS, that's A plus B, where A is 5 by 2 and B is 3 by 2. So let's check it out for that. LHS, this is LHS. Left hand side, what is there in the left hand side? It's A plus B. So let's check it out. So it is again 2. 5 plus 3, that's 8 by 2. So that's 4 by 1. Let's check it out whether we are getting the same result when we just change the order. Change the order in the sense like, let's check it out for RHS. RHS, it's B plus A. I'm changing the order. First I'm writing B and then I'm writing A. So B plus A. What is B over here? 3 by 2. So let's write B 3 by 2 plus what is A over here? 5 by 2. Now 3 plus 5, that's 8. 8 by 2, which will give us 4 by 1, which is equal to 4 only, right? So we can see the result is same. So we can say that addition of rational number follows commutative property. Addition of rational number follows commutative property. Okay, let's check the same for subtraction of rational number. So in subtraction of rational number, what will happen? It will happen like A minus B should be equal to B minus A. Let's check it out for this. A is 5 by 2 minus 3 by 2. I am checking out for the LHS one right now. LHS, A minus B. Okay. So over here 5 by 2 minus 3 by 2, which will give us 5 minus 3. That's 2 by 2. That's equal to 1. Okay. Now let's check it out for the RHS. It's B minus A, right? So let's check it out for B minus A. B is 3 by 2 minus 5 by 2. It's B minus A. So again it will be 2 and it will be 3 minus 5. That's equal to, see, plus minus minus we have already done in integers, plus minus minus and sign of the greater number. So 5 minus 3 will give us 2. But sign will be of greater number, that's 5. So minus sign. So 2 ones are 2 ones are. So it will have minus 1. And we know that 1 is not equal to minus 1, right? So this property doesn't hold for subtraction. Okay, this property, commutative property, is not true for the subtraction of rational number. Is it clear? When we have the same result, even after changing the order, then we say that this property holds, commutative property holds. So over here in the subtraction case, we have seen that the result is not same. So commutative property doesn't hold for the subtraction of rational number. It holds for the addition of rational numbers. Now let's check it out for the multiplication also. Same number I'm going to take. Let the first rational number be 5 by 2. It implies that A into B should be equal to B into A. So let's check it out. 5 by 2 multiplied by 3 by 2. Okay. So A into B. A is 5 by 2 and B is 3 by 2. So 5 into 3, that's 15. And 2 into 2, that's 4. 15 by 4. Now I'm doing, this is for the LHS one. Now let's check for B into A. That's RHS. This is for A into B. Let's check for B into A. So B into A is what? This is 3 by 2 multiplied by 5 by 2. 3 into 5 is 15 and 2 2s are 4. Is the result different? No, it's same. So result is same over here. So commutative property holds for multiplication of rational number also. So let's check it out for division of rational number. For the same thing we'll see. It should be like A divided by B should be equal to B divided by A. A is 5 by 2 divided by B by 2. B is 3 by 2, right? So we already know the process that the first fraction is written as it is, first rational number, and then division changes into multiplication and this gets reciprocal, so 2 by 3. We are solving for the LHS, that's A divided by B. So finally we are having 5 by 3. Let's check it out for the same in RHS side. RHS we have what? We have B divided by A. What is B over here? It is 3 by 2 divided by 5 by 2. So 3 by 2. Division will change into multiplication. Those who are having doubts with the calculation of this or the operations, how we have to do it, they can see the previous video. It's already given there, addition, subtraction, multiplication and division of rational number in my previous video. So here 2 by 5. So now 2 will get cancelled and finally we are having what? 3 by 5. Is the result same? No, they are not same. Okay, so it doesn't hold for division, it holds for multiplication. Okay, so commutative division of rational number is not closed, it doesn't follows commutative property. Okay, it follows commutative property is only applicable in addition of rational numbers and multiplication of rational number. It doesn't follows for subtraction and division of rational numbers. Okay, I hope so it is clear. Now let's move on to the another property, that is associative property. Here we will take three numbers. Let's take A, B, C are three numbers. A, B, C are three rational numbers. And here what we have to see, that if I have to see the grouping of numbers. How? Let's see. A plus in bracket B plus C should be equal to A plus B plus C. It says that associative property states that even if we change the grouping of the numbers, like here you can see I have taken a group of B and C, the second number and the third number, and whatever sum will come, I will just add that sum with the first number, that is A. Now I have changed the group. It is A plus B, first number and the second number, I have taken it together, and whatever the sum will come, I will just add up with the C. So this is for the addition. We'll check out for addition, subtraction, multiplication and division for all the operations. Okay. So what it says that even if we change the group of numbers, the result will remain same. So let's check for addition of rational numbers. So over here it is like a plus b plus c should be equal to a plus b plus c. So let's take a over here. I'm taking a as 1 by 2, b as 3 by 2 and c as 5 by 2. Okay, I'm taking a simple number so that it becomes easier for you all to understand. So here a plus b. So here what I will do here, a plus b. So a is what? 1 by 2 plus b is what? 3 by 2 plus c is what? 5 by 2. So here I have grouped this b and c. So I have to solve this one first. So let's check it out. I'm solving LHS. That is this part. A plus in bracket b plus c. So it will be 1 by 2 plus this I'm solving 3 plus 5, that's 8. So it is 1 by 2 plus 8 by 2, that's equal to 9 by 2. Okay, now let's check it out for the RHS side. Okay, let's see whether the result is coming same or not. So it says that a plus b should be in the bracket. So a plus b plus c. Let's solve this bracket first. So it will be 2. 1 plus 3, that's 4. 4 by 2 plus 5 by 2, which will give us 9 by 2. Yes, we got the same result. Okay, so we can say that associative property holds true for addition of rational number. Okay, let's check for subtraction of rational number also. So what I will do, I'll just change the sign. It will be a minus b minus c should be equal to a minus b minus c. Again I will check for the same. Here you can see, you can write it over here, LHS is equal to RHS. So it is true. Okay, over here let's check it out for the LHS part. LHS is what? A minus in bracket b minus c. So what is a here? 1 by 2 minus b is what? 3 by 2 minus 5 by 2. So we'll solve the bracket first. So let's take it here. So denominator is same. So 2, it will be 3 minus 5. So we will have 1 by 2 minus 5 minus 3 is 2. But the sign of the greater number is negative. So we'll have minus 2 by 2. Now we know that we have already studied in our integers part, like minus minus will become plus. So we'll have plus 2 by 2, that's equal to, I'm not cancelling out here, I'm just adding them 2. So 2 plus 1 is 3 divided by 2, 3 by 2. Let's check it out for the RHS part, whether the result is same or not. If it is same, then it will also hold associative property. If it is not same, then it will not hold for associative property. So let's check it out for that. A minus b, RHS. What is RHS here? A minus b in bracket minus c. So let's check it out. A is half minus 3 by 2 minus 5 by 2. So we'll solve the bracket. So we'll have 2, 1 minus 3 minus 5 by 2. So 1 minus 3 is minus 2 by 2, right? Minus 2 by 2 minus 5 by 2. So minus minus plus, and sign will be same. So it will be minus 7 by 2. So we observed that the result is not same. Here LHS is not equal to your RHS. So associative property holds for subtraction. No, it doesn't hold for subtraction of rational number. It holds for addition of rational number. Let's check for multiplication as well. So here in multiplication we'll see it's A into B into C. A multiplied by, in bracket, B multiplied by C should be equal to A multiplied by B. Basically we are changing the groups over here, group of rational numbers. Okay, so A is what? 1 by 2, B is 3 by 2 into 5 by 2. We are solving LHS. So what we'll observe here? We'll observe that 1 by 2, 5 3s are 15, 2 2s are 4. So we'll have 15 1s are 15 and 4 2s are 8. Okay, we solved for LHS part. Now let's solve for the RHS as well. A multiplied by B. So it is 1 by 2 multiplied by B. That's 3 by 2 multiplied by 5 by 2. So here 3 multiplied by 1 will be 3 and 2 2s are 4 multiplied by 5 by 2. So 5 3s are 15 and 4 2s are 8. Yes, I got the same answer. It's 15 by 8 over here also and 15 by 8 over here. So there is no change in my result even if I am changing the groups in addition and multiplication. Let's check for, we can write here LHS is equal to RHS. So let's check for the division part now. In division, again the same thing we'll see with the pre-rational number. A divided by B divided by C should be equal to A divided by B divided by C. Okay, so let's check out for this. A is 1 by 2 divided by B is 3 by 2 divided by 5 by 2. I'm solving LHS, left hand side expression. So here 1 by 2 divided by, we'll have to solve the bracket first, 3 by 2. Division will change into multiplication and this will be becoming reciprocal. So we are having this. So it is 1 by 2 divided by 3 by 5. 2 got cancelled. So we are having 3 by 5. 3 1s are 3, 5 1s are 5. Now it is 1 by 2. Again division will change into multiplication and this will get reciprocal, 5 by 3. So we are having 5 1s are 5 and 3 2s are 6. So we are having 5 by 6. Now let's check for RHS part as well. Okay, so RHS, we are having A divided by B divided by C. So A is 1 by 2 divided by 3 by 2 whole divided by 5 by 2. So we'll solve the bracket again. 1 by 2. Division will change into multiplication, 2 by 3 divided by 5 by 2. So 2 will get cancelled and we are left with 1 by 3 divided by 5 by 2. So let's check it out for this as well. So it will become 1 by 3 multiplied by 2 by 5. So it will have 2 by 15. So the result is not same over here. It's again different. It is 5 by 6 over here. It is 2 by 15 over here. Okay. So it doesn't hold for division of rational number also. So associative property holds only for addition and multiplication. It doesn't hold for subtraction and division. Okay, we have seen by example. I hope so it is clear to you all. Let's check it out for the distributive property of multiplication over addition. So over here what we have to see, it states that if A is being multiplied with B plus C, then we can multiply A into B and A will be multiplied with C also. Okay, A multiplied by the sum of B and C, then A is being multiplied with B and A is multiplied with C also. So we'll see whether it is true or not. So let's check it out. Let's take A as 5 by 8, B as 7 by 4, okay, and C as 2 by 3, okay. Now we'll see for this. A, LHS 1, A into B plus C. Now what is A over here? A is 5 by 8 multiplied by B. B is what? 7 by 4 plus 2 by 3. C is 2 by 3. Now as the denominators are different, so we'll have to take out the LCM, and it's a co-prime number, so we can simply multiply them. 4 3s are 12. So the LCM is 12 over here. So we'll just do it like this. 5 by 8 multiplied by 12. So here 4 3s are 12. So 7 3s are 21. 21. 3 4s are 12. So 2 4s are 8. Now we are having 5 by 8 into 29 by 12. We cannot cancel anything. So what is our final answer? Our final answer is 145 by 96. 12 8s are 96. So here 145 by 96 is our answer. Let's check it out for the RHS part. This is our LHS. Let's solve for RHS also. It is A into B plus A into C. A multiplied by B plus A multiplied by C. Now we'll do A is what? 5 by 8 multiplied by 7 by 4 plus 5 by 8 multiplied by C is 2 by 3. So we'll multiply here, we'll get 7 5s are 35, 8 4s are 32, plus 5 2s are 10, 8 3s are 24. Now as the denominators are different, so we'll take out the LCM. We know it, we have already done in our previous video. When the denominators are not same, we have to take out the LCM. So let's do it for 2 with 2. 2 1s are 6 ja, and 2 1s are 2 2s are. Then 2 8s are 2 6 ja, 2 4s are 2 3s are, 2 2s are, 3 will be written as it is, 2 1s are 3 and 3 1s are done. So let's see. 2 2s are 4, 4 2s are 8, 8 2s are 16, 2s are 32, 3s are 4, 3s are 96. Okay. So our LCM is 96. So we'll copy down the LCM. So let's see how we are going to solve it. So here 96 will write. How much we are going to multiply with 32 to get 96? I think 3. So 32 into 3 will multiply. So here same number we will multiply. Here also we'll have 105. 5 3s are 15, 3 3s are 9, plus 1 10. So here 24 4s are, okay. So here 10 into 4 will do, we'll get 40. So finally our answer is 145 by 96. Yes, result is same. Okay, so we can say that multiplication of rational number is distributive over addition of rational numbers. Okay, now we'll see for distributive property of multiplication over subtraction. Okay, here what is there? Here also same thing, a multiplied by b minus c should be equal to a into b minus a into c. So we'll say check for LHS part, that is a multiplied by b minus c. So what is, let's take a different number again over here. Let's take a as 1 by 2, b as 3 by 2 and c as 5 by 2. Okay, so here a is 1 by 2 into b minus c. So b is 3 by 2 minus 5 by 2. 1 by 2 into, we'll solve this. 3 minus 5 is 2, 5 minus 3 is 2, but the sign of the greater number, that's minus 2 by 2. That's minus 2 by 4, or we can say minus 1 by 2. Okay, let's check out for the RHS part. This is our RHS part. Okay, so we'll check out for this, a into b minus a into c. A into b means a is 1 by 2 into b. B is 3 by 2 minus a into c. That's 1 by 2 multiplied by 5 by 2. Okay, so it will be 3 by 4 minus 5 by 4. Okay, so here there is denominators are same, so we'll just copy down the denominator over here, and it will be 3 minus 5, that's minus 2 by 4. When we'll cancel, simplify, 2 1s are 2, 2 2s are 4. Again we are having the same result. Okay, so we can say that multiplication of rational number is distributive over subtraction of rational number also. Let's check it out for the next property, that is additive inverse. What is additive inverse? Like here, if I ask you what is the additive inverse of 3 by 4, you'll say minus additive inverse. Of 3 by 4 is minus 3 by 4. What is basically additive inverse? It says that what number you're going to add with the particular number so that the sum is 0. Okay, so suppose if 3 by 4 is there, what I'm going to add with this so that the sum is always 0. 0 is what? Additive identity. 0 is called a additive identity. Okay, so what I'm going to add? Obviously the negative part of it, if I'm going to add, I will get what? Minus 3 by 4. I will get 0. If suppose negative number is given, suppose 2, I'm taking 2 right now. 2, what I'm going to add with minus 2 to get 0? Obviously the positive part of it, that's 2. 2 minus 2 will give us 0. Okay, if I'll ask you what we are going to add with, suppose you just make it 8. What you are going to add with 8 so that your result is, your sum is 0. So obviously if I'll add the negative 8, I'll get 0. Plus minus minus, so 8 minus 8 will give me 0. So if it is asked that what is the additive inverse of 2 by 3, you'll simply say minus 2 by 3. If somebody asks you what is the additive inverse of minus 4 by 5, you'll say 4 by 5. If it is negative, the additive inverse will be written in positive. If it is it's a positive rational number, the additive inverse of that positive would be written same number with a negative sign. That's it. Now here, let's see the last one. That's a multiplicative inverse. Now multiplicative inverse is what? Inverse. Multiplicative inverse, it's simply, you can know by the name reciprocal. Reciprocal, okay? So what it is basically, like here, if I'll ask you what is the multiplicative inverse, I'm writing MI, inverse of 2 by 3, do the reciprocal of it. Reciprocal means denominator will come into the numerator part and numerator will come in the denominator part. That's it. That's 3 by 2. Okay. Now if I ask you what is the multiplicative inverse of minus 3 by 5, it will be 5 by minus 3. So multiplicative inverse is nothing but it's just a reciprocal of a number. I hope so. I have made it all clear from my end. Thank you so much for watching.